My name's Charles Godfray, I'm a population biologist and I'm based at the University of Oxford. Within Target Malaria, I lead a group based at the University of Oxford modelling different aspects of the spread of a homing endonuclease or other gene and the consequences it might have for a population. What I hope to achieve is first of all to support the rest of the project. So when one's trying to do an intervention such as using a homing endonuclease to either replace a population or to suppress a population, it's a very complex process, and the only way one can try and talk through how that happens is by using the language of mathematics. If you look at the tremendous progress that we've made in trying to reduce the burden of malaria, especially in developing countries, it is at risk, and it is at risk because we see resistance arising to insecticides and the vectors, and resistance in the parasite itself to the drugs that we currently use to treat the parasite in people. And we don't have many things in our armory, many things, to mix a metaphor, on our back shelf. So some of these new ideas that are coming out, these genetic interventions and gene drives, are hugely worth investing. We don't have the luxury, I believe, not to invest in these new techniques. The function of modelling is not just prediction, it's very much to help us to try and understand these very complex processes. So modelling is just not prediction, it's a much more varied type of function that we perform in the project. So if we have good enough data, then we can say things like how fast we expect the gene to spread through the population. We need two types of information. We need information that is largely genetic that we can obtain in the laboratory. So we're interested, for example, in the frequency with which the gene goes from one generation to the other. And without any disrespect to the wonderful people who spend a huge amount of time collecting this data, it is the relatively easy data to collect. What we also need is data about how these insects perform in the environment, and that's much harder to collect. It's much harder because the environment is much more variable, and it's harder because it is just more difficult to do experiments in the field than in the laboratory. So it's those two types of data that we need, and both are really important.